Welcome to this video on integration. In fact, it's part of my series videos on integration. I think I'll start with the first one here, then go to the second one if time allows me. And the first one requires us to remember the concept of inverse of a trigonometric function, because the integral of this one is an inverse of tangent, and there is a way we relate this one to the inverse of a trigonometric function. And maybe to have a quick recap of that is if you have a rational function, let's say you are given 1 over a squared x squared plus b, and you are told to integrate this, the solution or the antiderivative is usually 1 over ab tan inverse of ax over b plus a c. So even in this situation, we are going to use the same application, and we come up with the antiderivative of that. So let us relate very fast. The denominator is x squared plus 4, and we equate this one to a squared x squared plus b squared. Should be b squared here, and my coefficient of a from here, it's like a squared is a 1, because the coefficient here is a 1. So meaning that a is equals to 1 when if you square root. 4 is relating to b squared, so we have b squared is equals to 4, so b is a 2, okay, when you square root. Okay, great. So it means now we can substitute this one in our formula, and so our integral of 1 over x squared plus 4 dx is equal to 1 over a is 1 and b is 2, so that's 2. Tan inverse of a is 1, so we know x over b is 2, then plus a constant of integration. So it relies on you remembering how this one is related to a trigonometric function and inverse, to just say the least. Okay, so we go to the next question here. It is a combination of rational functions, and among them is also a trigonometric function. So solution, to integrate 1 over x, to integrate, I mean, use a different pen. To integrate 1 over x, we have a natural log of x, so that becomes a natural log of x. Integral of this one is like you take also the natural log, but then because the coefficient of x here is a 1, so it will also turn out to be natural log of x plus 2. And then the integral of this cosine of x here is plus sine of x, so it becomes now sine of x plus a constant. There's something I want to point out. If you let this is the answer, by the way. If you let your u to be x plus 2, then du is equals to dx in this case. Okay, so this is like when you're integrating 1 over x plus 2, dx is the same as integral of 1 over u, now that you say du to be x plus 2, and du is equals to dx. And when you have a fraction like this, 1 over something, the integral or the antiderivative of that is natural log of that. So this becomes a natural log of u plus a constant. But what is our constant? What is our u? I mean, our u is x plus 2. So you can see this becomes a natural log of x plus 2 plus a constant. So which is why when you have the integral of this part here, this 1 over x plus 2, it's that one. 1 over x, again, going by this fact, this is more or less like integral of 1 over x du, which turns out to be a natural log of u. And so this is the only bit that requires you to remember that the antiderivative of a cosine of a variable x is equals to sine of x, and vice versa is negative. If you have the antiderivative of sine of x is negative cosine of x, and that's it. So we'll stop there, and I hope that video has been of great help to you. We meet again in my next series of videos on integration and differentiation. Thank you.